Okay, so once again, our topic for today is about chi-square statistics. How about in research, no? The chi-square statistics is commonly used for testing relationship between categorical variables, as our presenter mentioned. No? The null hypothesis of the chi-square test is that no relationship exists on the categorical variables in the population, and they are independent. So an example research question that could be answering using a chi-square analysis should be, is there a significant relationship between voter intent and political party membership? So how does the chi-square statistics work? The chi-square statistics is most commonly used to evaluate test of independence when using a cross tabulation, or also known as bivariate table. No? So cross tabulation present the distribution of two categorical variables simultaneously with the intersection of the categories of the variables appearing in the cells of the table. So the test of independence assesses whether an association exists between the two variables by comparing the observed pattern of responses in the cells to the pattern that would be expected if the variables were truly independent of each other. So calculating the chi-square statistics and comparing it against critical value from the chi-square distribution allows the researcher to assess whether the observed cell counts are significantly different from the other expected cell counts. Okay, so of course we have f sub 0, no, the observed frequency, the observed counts in the cell, for example, and the f sub e, the expected frequency if no relationship existed between the variables. So a depicted in the formula, the chi-square statistic is based on the difference between what is actually observed in the data and what would be expected if there was truly no relationship between the variables. So how is the chi-square statistics run in SPSS and how it is output interpreted? It is also important, no? Because the chi-square statistics, no, appears as an option when requesting a cross tabulation, no? So of course the output is labeled chi-square test, and the chi-square statistics used in the test of independence is labeled person chi-square, no? And this statistic can be evaluated by comparing the actual value against the critical found in the chi-square distributions. No? But it is easier to simply examine the p-value provided by some statistical tools like SPSS, Excel, and so on to make a conclusion about the hypothesis with 95% confidence with the value labeled as if that signal should be less than 0.5. So is the p-value less than 0.5? If so, we can conclude that the variables are not independent of each other and that there is a statistical relationship between the categorical variables. So what are the special concerns with regards to the chi-square statistics? There are a number of important considerations when using the chi-square statistics to evaluate a cross tabulation because of how the chi-square value is calculated. It is extremely sensitive to sample size. So when the sample size is too large, almost any small difference will appear statistically significant. So it is also sensitive to the distribution within the cells, and the statistical tools gives a warning message if cell have fewer than 5 cases. And this can be addressed by always using categorical variables with limited number of categories, actually by combining categories if necessary to produce a smaller table. Okay, so I will show you an applications of Microsoft Excel actually, or chi-square test for independence in Microsoft Excel. That is for non-parametric.
The chi-square independence test is a method for testing if two categorical variables are related in a given population. Yeah. Before we get into further details on chi-square tests, let me clarify with you what do we mean by categorical variables here. What are the features of categorical variables? Yeah. They don't have any ordering, for example, number 1, number 2, number 3. There is no highest or lowest. We cannot arrange the variables. Yeah, so technically what I'm trying to say over here is that we can't say that one particular variable is superior compared to the other, Okay, therefore, yeah, looking into these particular characteristics, statistical computation is not viable. Okay, for example, like average for gender doesn't make sense. Yeah, let me share with you some examples of categorical variables. Hair color. Yeah, you might have someone who's having a red color. Okay, the hair might be blue color, green color, purple. Yeah, but let's say if I want to do some computation, let's say I'm finding the mean of hair color. Yeah, I add up, I find the average between red, blue, green, purple. Not making any sense. And I can't even arrange which is superior. A person with a purple hair is much more better compared to a person with a green hair. Not making any sense here. Marital status: married, single, divorced, widower. Now, you can't arrange. Yeah, probably single people are happier. Just kidding. Yeah, but you can't actually arrange them which is superior compared to the other. Yeah. Gender, male, female. Again, yeah, we can't arrange them. We can't rank them. Okay, and if I'm finding a mean, okay, between male and female, I'm not making any sense over here. Another example here would be education level. Yeah, an individual might have PhD, some might have masters, bachelors, or some have high school certificate. These are categorical variables. Yeah, therefore, if we would want to run, okay, any statistical tests, or we want to do any computation for categorical variables, we have to look into chi-square tests. The hypothesis for a chi-square test is written in such where the null hypothesis, we say the two categorical variables are independent. It means there is no relationship. Let's say I'm looking into the relationship between, I want to see whether gender, okay, has any impact on the type of education level they have. Yeah, so I would say if I'm writing null hypothesis, then I'll say that, okay, the gender and education level are independent. And for the alternate hypothesis, we'll say that the two categorical variables are dependent. Yeah, so that means there is a relationship between that two categorical variables. Yeah, so that's how we write our hypothesis. So to conduct the test, the chi-square test, there are several things that we have to do. For the first step, what we have to do is we need to get the observed frequency. Now, what is this observed frequency? The observed frequency is your data that you have collected. For example, you want to see whether is there any difference between gender and the type of education level that they have acquired. So then definitely you need data where you need to ask people what is their gender, and you need to ask, yeah, the level of education that they have obtained. So you need to record this data. This is your observation, the data that you have collected. Once you have your observed frequencies, then you need to calculate your expected frequencies. Yeah, and there is a formula to calculate your expected frequency, and I will delve into this in a moment when I show you an example how we calculate the expected frequencies. So once you have the observed frequency and you have the expected frequency, in the third step, you will calculate your chi-square statistics. Yeah, so this is the formula where you have your observed frequency minus your expected frequency. Okay, the value that you get, you need to square, and you divide with the expected frequency. Yeah, so these are the three steps that you have to do in order for you to get your chi-square statistics. Don't worry, I'll be showing you one by one on how to calculate all these frequencies and how to calculate this chi-square statistics. So let's look into an example. Yeah, we want to investigate whether gender and type of food preference in a restaurant is related. So our null hypothesis is gender and type of food preference are independent, and our alternate is gender and type of food preference are dependent. So the null hypothesis is telling us that the two categorical variables, which is gender and type of food preference, are not related. Yeah, and the alternate hypothesis is telling us that gender and type of food preferences are dependent. Okay, they are related. So I have the hypothetical data for type of food preferences. So assume that what I did was I stand outside a restaurant, and every customer that came to the restaurant, I recorded this thing. First customer came in, I recorded, okay, whether it's a male or female, and I recorded the type of food that was being sold in the restaurant, assuming that in the restaurant only 3 types of food types are being offered: burgers, roti canai, and pasta. So I recorded this data for 50 customers. Yeah, so can you see? These are my observed data. Yeah, so what I'm going to do is that from my observed data, I want to see what are the number of males, okay, prefer burger, what are the number of female prefer burgers. Now, in order to do that, I can use a pivot table. So let's construct a pivot table. So how do we do that? You can go to insert, yeah, the pivot table. Click on the pivot table. Table range. So what you do is that you click on the table range. This is what we want. We want gender and food. Yeah, you take it from the label itself. Yeah, so you have selected the data for the observation. And where do we want the data to be displayed? I want the data to be displayed on a new worksheet. And I click OK. So you can see over here, yeah, the pivot table will appear in a new worksheet. So what I'm going to do is that I'm going to take gender and I'm going to drag in the box over here which says rows. I'm going to take food and I'm going to drag into the section here which says column. Now, the frequencies that I'm looking for is food. Okay, so I have to take food and I need to drag into the section here which calls volumes. Yeah, just bear in mind in the volume section here, make sure that you have selected count. Yeah, it will automatically count for you. So this is the table. So technically this is a summary of my observation. How many males prefer burger, pasta and roti canai, and I have male, okay, that prefer pasta, burger, pasta and roti canai. Yeah. So now once we have our observed frequencies, our observed data, we want to move to the next step, which is we want to calculate our expected frequencies. Now, this is what I like to do. Before I begin, I like to create these 3 tables over here. Yeah, one, can you see observed frequency, expected frequency, and I put here chi-square. So I have male, female, burger, pasta, roti canai, grand total. Yeah, and I do the same thing. You just can copy paste this table 1, 2 over here and change so that you don't get confused. Yeah, here is observed and here is expected and over here is chi-square. Then what I will do is I will go to the pivot table which we have created just now. I'll copy this data over here. And I will paste the data into this table. So you can see what I've done is that I've done my first step, which is the observed frequency. Step 1 done. So for the next step, let's calculate the expected frequencies. Yeah. So let me show you an example using this formula here. Yeah. How do we calculate the expected frequency? Grand total row 1. So we are going to use mostly the grand totals here. Yeah, I have the grand total over here. Let me put it into a different color. And the grand total over here. Okay, so I'm going to use the grand total row. This is the grand total row. And I will times with the grand total column, which is here. Yeah, so these are the 2 values that are very important. Okay, and we will divide with the number of observations. So let's calculate the first frequency here. Put an equal sign. Yeah, so what I need to do here is I will take this grand total. I will times with the grand total here. Okay, and I will divide with the total number of observation here, 50. Okay, and I click enter. This is how I get the value. Okay, so you will do that for each of these. For example, let's say if it's going to be pasta, then you will do what? You will again take the grand total of female. Yeah, we put an equal sign here because we are talking about females, yeah, right? Then you will times with the grand total of pasta. okay, because we're going to talk about pasta. Then you will divide with the number of observations, which is 50. Enter. You will repeat the process for roti canai as well. Okay. Now, let me show you an example for male. What you will do, now you will not take the grand total of female anymore because we're talking about male. So what you do is that you will take the grand total of male. Okay. So what you do is that you'll put an equal sign here again. You will take the grand total. You will times with the grand total of burgers, yeah, because we are in the burger column here. Yeah, you will take burgers and you will divide with the number of observation. This is how you do it. Yeah, so but what I'm going to do here is that I'm going to show you a much more simpler method. Okay, so let's just remove all these values from here. So what you can do is you put an equal sign. Then we are calculating for female, remember? You take the grand total here for female, you times with the grand total of burger because we are in the burger column here, and you divide with the number of observation 50. Now, what you can do is that try to observe here. What we are doing is that 20, which is the grand total, and the number of observation, these two values we are going to repeat for pasta and we are going to repeat for roti canai. Therefore, what we can do is that we can log the values. Okay, we can make an absolute cell reference. How do you do that? You press function F4. Can you see now there is a dollar sign here? Yeah, it means we have logged the cell. You do the same thing for the number of observation. You bring your cursor here, you click function F4, and now you click enter. Now what you can do is, you see it's much more easier. You just need to drag this thing up to roti canai. See, you have already calculated. Now you don't have to do one by one. And you can now check whether your calculation is correct or not. Yeah, your grand total here should be equal to 20. Okay, I drag until here, and can you see this summation sign here? I just click on sum 20. So you're on the right track. Let's do for male now. Equal sign. So the grand total now will be for male 30 times with the grand total for burger divide by the number of observations. So we're going to do the same thing now. The grand total for male, which is 30, and the number of observation you're going to repeat for the subsequent two more cells here. Therefore, you can log the value. You bring your cursor here, click function F4, logged. Then for the number of observation, you do the same thing. Function F4, enter. Now you just drag. See, you have recalculated automatically. This will save you time. And now we want to see, did we get 30? Just highlight this whole cell. We put a sum here. 30. Correct. We are on the right track. So you see, even though if you calculate the sum, okay, for burgers, 10, 15 should be 25. Yeah. So it should be giving you the same value. Okay, even drag now this thing until the end here. See? So you are on the right track. So what you have done, you have already completed two steps. You have already obtained the observed frequency and you have already obtained the expected frequency. Next, what we are going to do is that we are going to now calculate what is our chi-square value. So for the chi-square statistics, we have to now comply to this formula, yeah, which is the, we have the, for each cell, we have to take the observed frequency minus the expected frequency, okay, square the value and divide with the expected frequency. Okay, so let me show you how we do it. So for the first one here, you click an equal sign. Okay, now because there is a power here, power of 2, so what you should do is you type here power. Can you see power here? Okay, so what do you want to do? What is the number that you want to power? Okay, so what we want to power is, we want to take 8, yeah, which is the observed frequency, yeah, we will be putting another bracket here. Yeah, there should be 2. Okay, we'll be taking the observed frequency, and then we are going to minus the expected frequency, which is 10. Yeah, so it's 8 minus 10. I'm going to close this bracket. Yeah, remember now we've already put the number already. Comma. Okay, put a comma and power. You want it to be the power of 2. You close the bracket. And what you want to do, you want to divide this value, okay, on the power of 2, you want to divide with the expected frequency again, which is 10. Enter. So it's 0.400. Okay. So you want to try this again. Let me show you once again so that it's clear to you. Yeah, what we can do is now can put an equal sign, type in power. Okay, you have your bracket here. Okay, then you open another bracket. You take your observed minus your expected. You close bracket. Yeah, and then you have a comma over here, and you need to put your power now. Okay, your power is 2. You close the bracket, and you want to divide this value. Okay, it's the power of 2. You want to divide this value with the expected 10. Enter. So now it's very easy. You only have to calculate for once, and you can already calculate for all. What you do is that you take, can you see one small box is appearing here? Yes, you drag until here, and then you drag this thing down. So you have already calculated all the values over here. Now we have not get our chi-square yet. How do we get our chi-square? Okay, this is how we get our chi-square. We want the sum over here. So how do you get the sum over here? You take your cursor, you just highlight all this cell, and then you can put this sum value. See? Then again the same thing, and then you put the sum value. Now you have already got the sum over here. You again highlight this entire cell, you already get the sum value. See? So this 1.719 is your chi-square statistics. So I'm going to highlight the chi-square value. Yeah, so our chi-square statistics is 1.719. Now, in order to make decision, we have two approach. We have the critical value approach and we have the p-value approach. Yeah. So for chi-square distribution, yeah, for the critical value approach, this is the formula that we will use in our Excel, okay, to compute the critical value, which is chi-sq.inv.rt. Now, when we select this formula of function in Excel, there are two things that we need to know. We need to know what is the probability and we need to know what is the degree of freedom. So let's say we are using a significant level of 0.05. Yeah, so that will be our probability, 0.05. And we also have to calculate the degree of freedom. How do we calculate the degree of freedom? We have to take the number of rows minus 1, and we have to times with the number of columns, okay, in our cross tabulation, minus 1. Yeah, so we have to find these two values and then we times. Yeah, so let me show you. So before we calculate our critical value, we will calculate the degree of freedom. Yeah, so first we need to know what is the number of rows. Yeah, so the number of rows are 1, 2. Yeah, female, male. So 2 minus 1, the value here will be 1. Yeah, and how many columns are here? Burger, pasta, roti canai. There are 3 columns. Yeah, therefore C is 3. 3 minus 1, it will be 2. So how do I get my degree of freedom? It's 1 times 2. Therefore, my degree of freedom here is 2. Yeah. Let's calculate the critical value. You put an equal sign here and you put in the formula is chi-square, this one, chi-square INVRT. Yeah. So they are telling us to put in the probability. Remember, the probability is equal to your significance level that you have selected. So it's 0.05, comma, degree of freedom we have just calculated is 2. You put in enter. So our critical value here is 5.991. Yeah, so we have the chi-square statistics, and now we also already have the critical value. Yeah, let's put it into a diagram to see how do we make our conclusion. So this is our distribution here. Yeah, so you can see our critical value was 5.99. Yeah, so we have our chi-square distribution. So our critical value is 5.99. So this is our rejection region. But what happens is that the chi-square statistics, the value is 1.72. So it falls under the non-rejection region. Yeah. So if we see the chi-square statistics 1.72, okay, 1.72 is smaller than the critical value. Yeah, therefore what we do is that we fail to reject the null. Yeah, so if we fail to reject the null, it means gender and type of food preferences are independent. Yeah, therefore there is no relationship between them. Yeah, they are not related. Yeah. So this is how we can use the critical value approach. I would like to emphasize, yeah, please know this decision rule. Yeah, if your chi-square statistics is greater than the critical value, you reject the null. And if your chi-square statistic value is smaller than the critical value, then you fail to reject the null. Yeah, this is the decision rule. The next approach is the p-value approach, where again we can calculate the p-value using the Excel, and the formula for Excel is chi-square.test. Yeah. So again, the same thing if the p-value is less than the alpha. So for the alpha, let's say if it's 0.05, if the value is lesser than 0.05, then we reject the null. And if the value is greater than the alpha, we fail to reject. So we're going to compute the p-value over here. Yeah, you put the equal sign. So it's chi-square test. Yeah. So what the formula is trying to tell you here, they want the actual range and the expected range. So what is the actual range? It's here, your observed range here. Yeah, the actual range. Then you put a comma here, and then you select your expected range. Then you close bracket, enter. So you can see this is your p-value. Let me highlight it for you. It's 0.423. Yeah, so what is this value telling us? So the p-value is 0.423, and the alpha level that we selected was 0.05. Yeah, and you can see our p-value here is greater than the alpha, which is a significant level. So we fail to reject. Therefore, the conclusion using both the critical value approach and the p-value approach is the same. Yeah, therefore we can say that, yeah, the two categorical variables, which is gender and the type of food preference, are not related.